There are plenty of things that could kill you in space, from running into a star to being crushed by a black hole. But one of the most terrifying threats comes from the smallest and seemingly most inoffensive objects in the cosmos, white dwarfs. White dwarfs are incredibly dense, hot remnants of dead stars. And if you fell into one, it would tear your body apart atom by atom. Welcome to my channel. And today we're answering the question, what if you fell into a white dwarf star? First, let's answer the bigger question, what is a white dwarf? A white dwarf is the leftover core of a star like our Sun after it runs out of fuel and throws off its outer layers. This process doesn't happen until the star has been around for billions of years, and scientists think our Sun will do the same thing in about 5 billion years. But even though white dwarfs are pretty common in the universe, they're very difficult to observe since they don't emit much light. White dwarfs only glow because they're still very hot. They can have surface temperatures up to 30,000 degrees Fahrenheit or 16,500 degrees Celsius. That's about 2,000 times hotter than the Sun's surface. And their lines remain hot for millions of years before they cool off and fade away into the darkness as a black dwarf. But while they're still shining, white dwarfs are some of the densest objects in the universe. If you took the mass of the Earth and compressed it down to the size of a white dwarf, which is roughly the size of Earth, the density would be over 10 trillion times greater than the Earth's current density. To put that in perspective, the average human body has a density of about 1 gram per cubic centimeter, but the matter inside a white dwarf is compressed down to about 1 million grams per cubic centimeter. That means if you were to fall into a white dwarf, it would be like trying to walk through a brick wall. The pressure would be thousands of times greater than the Earth's atmosphere, which is already enough to crush a human body. But there's more. White dwarfs also have powerful magnetic fields that can reach millions of times the strength of Earth's magnetic field. So, if you manage to get past the crushing pressure at the surface, you would get very far before you were blasted back out again by the intense radiation and heat. And here's another scary fact. Some white dwarfs rotate so fast that their surfaces are covered in massive storms. These storms can blow with speeds of over 180 miles per hour or 300 kilometers per hour, which would make it impossible to stand upright on the surface. Not to mention that the surface of these white dwarfs ain't really solid either. It's more like a thick fog made of hydrogen and helium. So, what would actually happen if you tried to land on a white dwarf? The first thing you'd notice is that it would be hard to find a white dwarf to land on in the first place. Even though there are probably trillions of them scattered across our galaxy, they are so dim and difficult to detect that scientists have only identified a few hundred of them so far. Most of the white dwarfs that we have discovered are part of binary systems where they repaired with another star. And if you tried to sneak in for a landing, you'd have to be very careful not to get sucked into the other star. But if you somehow manage to navigate your way to an isolated white dwarf without getting burned up by its intense heat or blown away by its powerful winds, you might think you've made it. But once you got close enough to the surface, the gravity would start pulling you in, and the further you fell, the stronger the gravity would get. White dwarfs have a very strong gravitational pull due to their extreme density. In fact, the gravity on a white dwarf's surface can be hundreds or even thousands of times stronger than Earth's gravity. That means if you fell onto a white dwarf, you'd be pulled in at a very high speed. And as you approach the center of the star, the gravity would become even more intense. At some point, the gravity would be so strong that it would start tearing your body apart. As you got closer and closer to the center, the gravity would literally stretch your body out like spaghetti. This process is called spaghettification, and it happens because the gravity is so strong near the center of a white dwarf that it pulls on one side of your body more than the other. The difference in gravity between the two sides would be so great that it would literally stretch you out until you were a thin noodle. Of course, this would all happen in a fraction of a second, so you probably wouldn't even have time to react. But if you were somehow still alive after being stretched out like spaghetti, you wouldn't be for long. As you continued to fall towards the center of the white dwarf, you'd be met with even more intense pressure and temperature. At some point, the pressure would become so great that it would start crushing you. The further you fell, the more compressed your body would become until you were nothing but a pancake. Eventually, you'd reach the center of the white dwarf where the pressure and temperature would be at their greatest. Here, the pressure would be hundreds of millions or even billions of times the pressure found in the Earth's core. The temperature would be thousands of times hotter than the surface of the sun. At this point, your body would be completely crushed and vaporized. You'd be torn apart atom by atom and then reassembled in a form that's unrecognizable as human. But what if you somehow managed to survive all that? What if you remade of some special indestructible material that can withstand thousands of times the pressure and temperature of a white dwarf? Well, even if that were the case, you wouldn't stay that way for long. That's because white dwarfs also have very powerful magnetic fields. These magnetic fields can be millions of times stronger than the Earth's magnetic fields. And when you entered the white dwarf, those magnetic fields would start pulling on any iron or other magnetic materials in your body. The magnetic fields would tear apart your body and turn you into a jumbled mess of atoms. Even if you weren't made of anything magnetic, you still wouldn't last long inside a white dwarf. That's because white dwarfs also emit a large amount of radiation. This radiation is mostly in the form of ultraviolet light and X-rays, which can be very harmful to human cells. Even if you managed to survive the intense pressure and temperature, you wouldn't be able to survive the radiation. Your body would be bombarded with radiation from all sides, destroying your cells and turning you into a radioactive mess. Now, what if you had some kind of force field that could protect you from the radiation? Well, even then, you wouldn't last long. White dwarfs also emit a strong stellar wind. This is a stream of charged particles that flows away from the surface of the star. The stellar wind can travel at speeds of hundreds of kilometers per second, and if it hit your force field at just the right angle, it could knock you off course and send you hurtling towards the white dwarf. Once you made contact with the star, you'd be vaporized instantly. In short, falling into a white dwarf would be a fate worse than death. Your body would be torn apart, crushed and vaporized. There's no chance of survival. Now, of course, this is all hypothetical. No human has ever fallen into a white dwarf, so we can't say for sure what would happen. But based on everything we know about these stars, it's safe to say that you wouldn't survive the experience. So, if you're anywhere near a white dwarf, watch your step because, thank you for watching, What If? And thank you for watching, What If? And I'll see you next time.